Hi everyone, in this video we're going to discuss about Bayes theorem. So before moving on to Bayes theorem, we shall discuss some of the terms that we need in Bayes theorem. So the one such term is compound probability. So what is compound probability? It is a probability of simultaneous occurrence of two or more events. That means if we have two events or three events, then the simultaneous occurrence of those events are called a compound probabilities. So, if we have two events, say A and B, then probability of A intersection B is their compound probability. Similarly, if we have three events A, B, C, then probability of A intersection B, probability of B intersection C, and probability of A intersection C, and probability of A intersection B intersection C are called the compound probabilities. So next we're going to discuss about marginal probabilities. So for marginal probabilities, we are going to split our sample space. Suppose we have a sample space S. We are going to split that sample space into R partitions such that A1, A2, etc. AR are disjoint and mutually exclusive events. So we are going to partition the sample space into A1, A2, etc. AR mutually exclusive events. Similarly, we are going to partition the same sample space S, capital S, into S partitions, that is B1, B2, etc. BS, such that B1, B2, etc. all those values are also disjoint events. Then we can write A1, since we are partitioning the same sample space into two, or like A1, A2, etc. AR, and the same sample space is partitioned into another set B1, B2, etc. BS, we can write A1 in terms of A1 intersection B1 union, A1 intersection B2 union, etc. A1 intersection BS. And since B1, B2, etc. BS are said to be disjoint and mutually exclusive, we know A1, B1, that is A1 intersection B1, and A1 intersection B2, etc. A1 intersection BS are also mutually exclusive. Why? B1, B2, B1, B2, etc. BS are mutually exclusive, and A1 intersection B1 will be either B1 or will be a subset of B1. So they are also mutually exclusive. So we can write probability of A1 as probability of A1 B1 union, A1 B2 union, etc. union A1 BS. Now we know A1, all these are mutually exclusive. Therefore, probability of A union B can be written as probability of A into probability of A plus probability of B if those A and B are disjoint. So similarly, we can use that property here. That is, we can write that probability as the union as the sum of probabilities. So the marginal probability of A1, that is here the probability of A1 is called the marginal probability, because we are going to find the probability of that particular event. That can be written as sum of these compound probabilities. So the marginal probability can be written as a sum of compound probabilities here. And here the probability of A1 is called the marginal probability of A1. Now we are going to move on to the Bayes theorem. So if an event A can happen if and only if one or the other set of an event and set of a mutually exclusive events B1, B2, etc. Bk happens, and if probability of Bi for I equal to 1 to etc. k is not equal to 0, then we define the Bayes theorem as probability of Bi given A is equal to probability of Bi into probability of A given Bi divided by summation over I probability of Bi into probability of A given Bi. So the proof for this Bayes theorem is as follows. So first of all, we know using the conditional probability, probability of A intersection B can be written as probability of A into probability of B given A. So using that property, we can write probability of A intersection BI as probability of A into probability of BI given A, which can also be written as probability of BI into probability of A given BI. So, that intersection can be written in terms of the conditional probability. So, probability of BI given A, from the first line we'll get probability of BI given A as probability of BI into probability of A given BI divided by probability of A. So now A can happen if and only if one or the other of mutually exclusive events B1, B2, etc. Bk happens. So A can happen in K mutually exclusive ways. That is A B1, A B2, etc. A Bk only. Why? Because in the previous section we have discussed what are marginal probabilities. So we are going to use we need the probability of A. That means probability of A means it is a marginal probability thing. So A can happen in K mutually exclusive ways where A B1, A B2, etc. A Bk. Therefore, we can write A as A B1 union, A B2 union, etc. union A Bk. So, probability of A can be written as probability of unions, probability of this unions, which can be written as summation of each term. Probability of A B1 can be written as what? We can write it in terms of conditional probability. A B2 can be written in terms of conditional probability, and A Bk can also be written in terms of conditional probability. So that can be written as A B1 can be written as probability of B1 into probability of A given B1. Probability of A B2 can be written as probability of B2 into probability of A given B2, and similarly A Bk can also be written in that way. So we will get probability of A as summation over I probability of Bi into probability of A given Bi. Therefore, in the second line we have the equation probability of Bi given A is equal to probability of Bi into probability of A given Bi divided by probability of A, where we can replace that probability of A using this summation term. Therefore, we'll get probability of Bi given A as probability of Bi into probability of A given Bi divided by the summation over I probability of Bi into probability of A given Bi for all those I equal to 1 to etc. k. So this is the proof for the Bayes theorem. So it's just a partitioning of a sample space, and we partition it into mutually exclusive events, and we use the properties that we have recently studied, that is the marginal probabilities and conditional probabilities and compound probabilities in this. Now we shall discuss about a question using this Bayes theorem. So for this we have two urns or two balls or something, like two groups or two bags, 1 and 2, containing respectively 3 white balls and 2 black balls, and the second urn has 2 white and 4 black balls. So there are 5 balls in total in first urn, and there are 6 balls in second urn. And 1 ball is transferred from urn 1 to urn 2. Then a ball is drawn from the latter, that is, a ball is drawn from the second urn. It happens to be white, that means the ball drawn is a white one. What is the probability that the transferred ball was white? So we need to find the probability that one ball is transferred is already said. So the transferred ball is white. So for that we define the event of drawing a white ball as event A. And similarly, let B1 and B2 be the event of transferring a white ball and B2 be the event of transferring a black ball. So, we define these three things. A as the event of drawing a white ball, and B1 as the transferring a white ball from urn 1 to urn 2, and B2 as a black ball is transferred from urn 1 to urn 2. Now, for the transferring of a white ball, we know in urn 1, that is in the first urn, we have 3 white and 2 black. So, for a white ball to be transferred, the probability is 3 by 5. And from the urn 1, that is from the first urn, for a black ball to be transferred, the probability is 2 by 5. Why? Because in total there are 5 balls, and out of which 3 are white and 2 are black. Okay, so now we know the conditional probability, that is probability of A given B1. So A given B1 is that is if a white ball is transferred, what is the probability of getting a white, or what is the probability of drawing a white ball? That is, if one white ball is added to the second urn, then we have in total 3 white and 4 black. So their probability of A given B1 will be, for that A given B1 will be 3 by 7. Similarly, drawing a white ball when a black ball is transferred is 2 by 7. Why? In total there were 6 balls, and 1 ball is transferred from the first turn to the second turn. So the total has changed to 7. And there are 2 white and 5 black. So drawing a white ball is 2 by 7. Now we require to find a probability that the transferred ball was white. Part of the transferred ball was white. So we need to find the probability of transferred ball was white given the ball drawn as white. So for that we have to find the probability of B1 given A, for which we can use the Bayes theorem. So probability of B1 given A is as follows, where we have probability of B1 into probability of A given B1 divided by probability of B1 into probability of A given B1 plus probability of B2 into probability of A given B2, using which we will get the answer as 9 by 13. So if a ball drawn was white from the second urn, then the probability that the transferred ball is white is 9 by 13. Thank you.